In this video, I'm going to discuss the notion of relevance and its relation or lack thereof to validity. This will be helpful in just understanding how what our logical system says and what it does, and that will be helpful in your ability to construct derivations. So, relevance. So you might think that the premises of a valid argument should be somehow relevant to the conclusion. But in our system, they do not have to be. There's no requirement that the premises be relevant to the conclusion, even if the argument is indeed valid. So let's consider some possible arguments in our system. So here's one argument. If premise 1 is P, premise 2 is not P, the conclusion is Q. Second argument, premise is Q, conclusion is if P then Q. Third argument is premise not P, conclusion if P then Q. So you might worry about these arguments. These arguments are indeed valid and they are derivable in our derivation system, but you might think that's a bad thing. You might think, look, there's no connection between the truth of the premises and the truth of the conclusion. In the first one, in what sense does the contradiction lead to Q? It doesn't. And in the second and third, you might think, we haven't shown that P, the antecedent of the conditional, leads to Q, and so the premises, but to show that a conditional is true, don't you need to show that the antecedent somehow leads to the consequent? And in a valid argument, shouldn't you show that the premises lead to the conclusion? Well, no. Simply put. Why not, you might ask? So, let's think first of all about just what our derivation system says, and then is that a good thing that our derivation system says that? And so I want to really distinguish two questions. Why are those arguments derivable, and then should they be derivable? So to box and cancel, all you have to do is make sure that the right sentences are beneath the show line. So there's no restriction on how the sentence got there. So if you have the consequent of a conditional, there's nothing that says that the consequent had to be gotten from an assumption of the antecedent. And if you have a contradiction, there's nothing that says that has to be got from the negation of the conclusion. It says, however the contradiction got there, we don't care. Now that it's there, you can box and cancel with ID. However the consequent of the conditional got there, did you get it from the assumption of the antecedent? Who cares? It doesn't matter. The consequent is there, you can box and cancel. You got a contradiction? Did it come from the negation of the conclusion? Who cares? As long as you got a contradiction, you can box and cancel. There's nothing in the rules of the system that say, oh, you have to have got the contradiction in the right way, and there's nothing in the rules of the system that say, oh, you have to have got the consequent in the right way. It's enough that you have the contradiction. It's enough that you have the consequent. That's enough to box and cancel by ID or CD, respectively. Now, there are things called relevance logics that do place such requirements. So they would say, for example, if you're doing a conditional derivation, it's not enough that you get the consequent on a line. It needs to be that the assumption is somehow cited in the lines leading up to getting the consequent. And again, they would say that, oh, it's not enough that you have a contradiction. Somehow, assuming the negation of the conclusion, that assumption has to be cited in the lines that lead up to the contradiction. However, that's clearly a more complicated system, because not only do you have to have the consequent of the conditional, not only do you have to have the contradiction, you have to have got the contradiction or the consequent in the right way. And so those things that are called relevance logics are much more complicated. Now, is a derivation system simple or complicated? Well, what do you think? Would you like to be using a more complicated one right now? I don't think so, right? And that's why we're working with our system. Because not only is it that it's simpler and that's nice, but the other ones build on it. So it's not just that they're more complicated, but they're complications of the system we're using. So even if you thought we should be using relevance logics, it's good to start with our system and then go to those more complicated systems later. Now, what about validity? So we really have two notions here. There's a notion of validity and there's a notion of derivability. Derivability, if you have an argument that says, can you in our system build a derivation of it? Note that there's nothing in there about the words truth or falsity, right? It just says, can you build this sequence of sentences and show lines and boxed and canceled show lines in the right way. There's nothing in there about truth. But whereas validity, so you might say, okay, fine, that's how our derivation system works, but I think those are invalid arguments. But that's not true. So given our definition of validity, we don't want a relevance requirement on our derivation system. So there are two equivalent ways to say what validity is, as we've defined it. One is, in every situation in which the premises are true, so is the conclusion. And the other is, there's no situation in which the premises are true, but the conclusion is false. And these are equivalent. These are two different ways of saying exactly the same thing. So what the second one says is there are no possible counterexamples to the argument. There's no way of saying, aha, you can't get from the premises to the conclusion because here's my example that shows you the premises are true and the conclusion is false. Here's my counterexample. So if we look at argument 1, this is P and not P, therefore Q. So on the one hand, the premises of 1 are both never true. Now that means there is no situation in which both the premises are true. And that means there's no situation in which both the premises are true and the conclusion is false. So there's no possible counterexample. There's no way to find a counterexample. A counterexample has to be true premises, false conclusion. But since the premises are never true, there's no counterexample. Now, this argument has, it's true that it doesn't have any counterexamples, and that's a good feature of it. It has other problems, like, for example, the fact that the premises can never be true, and so they could never actually believe in the premises. Rational belief in the premises could never, the premises could never give you good reason to believe the conclusion because you never have good reason to believe the conclusion, the premises. You always have, let me say that again. Could the premises ever give you good reason to believe the conclusion? No. Why? You could never have good reason to believe the premises. Why? Because they're obviously contradictory and can't both be true. So this isn't a great argument overall, but in terms of validity, it is a good argument. There's no counterexample to it. There's nothing saying true premises, false conclusion. So, yeah, as I say, right. So there's no reason to believe the conclusion on the basis of believing the premises because you would never have a good reason to believe the premises. So, how is this sort of important for doing your derivations? It means you want to understand that the system is not requiring, in some sense, that you sort of get from the premises and assumptions to the conclusion in the right way. All it requires is you be able to box and cancel. And however you get there, good. If you use assumptions, good. And you always want to make assumptions because they're they're usually helpful. But there's something that says they have to be used. And we want it that way, given our notion of validity. Notice that there's nothing in the notion of validity that says anything about relevance or relationship between the premises. It just says no situation in which the premises are true and the conclusion is false. There's nothing there about relevance. Now, I didn't talk about the second and third arguments in that I showed you at the start, the two ones whose conclusions were conditional. So I've just talked about this one, the one where the contradictory premises have no relationship to the conclusion, no relevance to the conclusion. I'm going to talk about the conditional arguments in the next unit. But for this argument, you want to note that in your homework, you're going to have a derivation that is basically like number 1. It has contradictory premises and then a conclusion where the conclusion doesn't contain any sentence letters from the premises. So you think, how could this possibly be derivable? There's no relationship between the premises and the conclusion. And the answer is, well, in a way, you're right, there's not. The premises are not relevant to the conclusion, but the argument is still derivable and valid. Why? Because the premises are contradictory. They're not quite as obviously contradictory as P and not P are, but they are contradictory, and that's the way in which you'll want to the way in which you'll complete that derivation is effectively by showing that the premises are indeed contradictory. Okay, so in the last brief video, I'm going to discuss the notion of theorems a little bit, and then we'll also have a few videos on homework review. And that'll be all the videos for this week. So great. See you in the last video.